Welcome to yet another lecture in the FPFF training series. In this, we will talking about some of the terms which are used in the context of firefighting. Okay, fire prevention and firefighting. Basic firefighting. It's a mandatory course. Every seafarer has to do it before he joins the ship or any offshore platform. So this module 2 we are going through, and this is chapter 3 of the module 2. In this, we will talk about relevant definitions, terms which are used in the firefighting training, firefighting purposes, and also in the FPFF course, so that you understand the meaning of those terms. All right, and then we'll proceed further. Introduce myself because you must know who is your trainer. So, welcome aboard. I am Sanjeev Mehta, and I'm your instructor for this module on fire prevention and firefighting. With over 2 decades at sea, and then in the maritime training, I worked in the training center, some of the ship management companies, and then I have been freelancing, doing many things, auditing, etc., and some training, of course. So this course is designed not just to inform you, just but to prepare you to act, think, and respond when it matters the most. Fire can happen anywhere, anytime, even on a ships. And on the ship, if it happens, it's devastating. It overwhelms the crew, all right? And a fear sets in. So you have to prepare yourself. Remember, fail to prepare means prepare to fail. So you must prepare before any incident occurs. So let's begin this voyage by understanding the fundamentals that could save lives, including yours. Some important terms are necessary for you to know before we continue with the course. Everybody who are attending the firefighting and fire prevention course must know them. Otherwise, also, it's good to know. Flashpoint. I think flashpoint I had explained in a module earlier also, but again, I'm explaining. Flashpoint is that temperature at which a flammable material gives off sufficient vapor which will catch fire if oxygen and the source of ignition is present. So, a flammable material will not burn unless it has reached the flash point temperature. Only after reaching that temperature, it will give off sufficient vapors, which will cause the fire to occur. In case, of course, now your oxygen must also be present. Ignition temperature. And what ignition temperature? The minimum temperature at which a material will spontaneously ignite without an external flame or source, or flame or spark. What does the meaning of that? If a material is you heating it up, it heats up otherwise also, and it is giving us sufficient vapor. At a flash point, will start giving us sufficient vapor. But those vapor will not catch fire unless a source of ignition is present, providing oxygen is present, air is present. But if the temperature continues to rise because of some other factors, these vapors will reach a temperature which is called ignition temperature, and at which they will start burning without any external source of heat being provided. For some reason, let's say the room is getting heated up, and vapors are being given off at flash point. They start coming out, and slowly they reach a temperature what is called ignition temperature. Then these vapors will start burning. That is the ignition temperature. Spontaneous ignition. It takes place when the flammable material is heated to its ignition temperature. So we know the ignition temperature is the temperature at which a vapors catch fire. Spontaneous ignition, sometimes this temperature is reached with like oxidation, which I was explaining. During oxidation, heat is given off. although the outside temperature or the temperature of the oily rag where they are kept is not that high, which will cause the ignition. Ignition temperature has not reached, but because of the spontaneous ignition, because of the oxidation taking place of the oil, which is the oil soaked rags, the oil is getting oxidation is taking place, temperature is rising, maybe on a limited area. Hmm. That reaches ignition temperature and it catches fire. So we say spontaneous ignition has taken place. So spontaneous ignition also takes place when when oxidation of flammable material takes place, like oil-soaked rags. Because of the oxidation of the flammable oil, heat is generated. Fire may occur without any apparent reason. Hmm? Flashover. The near simultaneous ignition of all combustible material is an enclosed space where temperatures are extremely high. Flashover. That means very fire spread very quickly. Simultaneously, all material which is present start igniting. Start fire takes place of all the material. Okay. Flammable material, inflammable also. It's the same thing. English language is confusing, nevertheless. A material which is capable of being ignited and burning, that is combustion, is a flammable material. For the purpose of our course, term flammable and combustible material are interchangeable and have same meaning. Also inflammable material. Fire extinguisher, portable devices used to put out the small fires. They are categorized by their extinguishing agent, foam, CO2, dry chemical. There can be 9 liters, 9 liters more common. There can be 36 liter also. They're kind of fixed actually. Portable ones are, which you can carry out, generally they are 9 liters. 36 one, you can say not exactly portable, but can be fire can be fought at a distance also, because the hose can be laid down. Fire detectors, devices that detect the presence of smoke, heat, or flame, triggering alarms to alert the crew. Because whenever smoke is present, whenever heat is present, large amount of flames are present, fire is likely to take place. That's why these fire detectors. Firefighting system, built-in system on ship such as CO2, which floods the engine room, for example, or the cargo hold, hyper mist sprinklers, or fire systems designed to extinguish fires in a specific area like engine room or cargo hold. Hyper mist has become very popular nowadays. We'll talk about hyper mist in a separate issue. Hyper mist basically is a sprinkler, but a much improved version. Hyper mist can be used even on electrical equipment. How? Why? Because in hyper mist, water particles are so small, but they large surface area because there are a number of them. The moment they fall, it evaporates, taking the heat away. So quickly it cools up the specific area where hyper mist spray has been aimed at. Very interesting. Okay. Breathing apparatus. A protective device providing a supply of clean air, allowing firefighter to breathe in smoke-filled environments. We need oxygen. If the area is filled up with the smoke, how to breathe? So we use the breathing apparatus. SCBA, commonly called self-contained breathing apparatus. Fire blanket, flame-resistant blanket used to smother small fires by cutting off the fire's oxygen supply. Smothering, fire dies down. The practice of applying water to adjacent areas of a fire to prevent heat transfer and contain the fire spread. Let us say economizer, exhaust gas boiler in the machine spaces on a fire. You, the casing you start spraying with a large amount of seawater. All right, so it will cool down. Inert condition, a condition in which oxygen contained throughout the atmosphere of a tank has been reduced to 8% or less by volume by addition of inert gas. Usually, it is referred to in context to cargo tanks or oil tankers. Actually, we earlier I had advised you, informed you, fire cannot sustain if oxygen percent is below 12%. But by mandatorily, inert condition means oxygen percent is less than 8%. So there is you can say a safety factor. All right, because 12% is touch and go, touch and go. So we make it much lower, 8%. Gas free. A tank compartment or a container is gas free when sufficient air has been introduced into it to lower the level of any flammable, toxic gases or inert gases to those required for a specific purpose. For example, hot water entry, etc. And usually it is also referred to in the context cargo tanks and oil tankers. All right. So it's said to be gas free because flammable range of you can say oil cargo vapors or hydrocarbon vapors is 1 to 11%. All right. So tank is considered to be gas free if the hydrocarbon percentage is less than 1% of the lower flammable limit. That means, in fact, 0.001% of hydrocarbon. Lower flammable limit. Flammable vapors to burn requires a minimum or lowest percentage of these vapors and air to get ignited when a source of ignition is introduced. All right. Some percentage of hydrocarbon or flammable material vapors has to be there. If the percentage of flammable vapors is below this percentage, mixture of flammable vapors and air will not burn, no matter how high is the temperature. This lowest percentage is called LFL or LEL, lower flammable limit or lower explosive limit. Similarly, we have higher limit also. Flammable vapors to burn requires a percentage of vapors and air to get ignited when a source of ignition is introduced. If the percentage of flammable vapors is above certain limit, mixture of flammable vapors and air will not burn. This is called HFL or HEL, higher flammable limit. So there is too much percentage of flammable vapor, hydrocarbon. Fire will not take place. Okay, too much of everything is bad. So generally, limit between LEL and HEL or HFL is called flammable limit, range of flammable limits. Generally, LEL and HEL limits refer to hydrocarbon vapor percent. Therefore, flammable range refers to hydrocarbon vapor percentage between the LEL and HEL. Flammable range. Flammable range for most hydrocarbon vapors is between 1 to 10%. A little bit variation, but generally is 1 to 10%. Hazardous area. An area on a tanker vessel, where electrical equipment which are installed must be explosion proof, also called flame proof. Why this area is called hazardous area? Where the hydrocarbon vapors are expected to be present and they are expected to be in the flammable range. That's why it's called hazardous area. So, an aggregation of bubbles having coherent relation and specific lower gravity than any lightest fuel formed by soapy water is known as foam. Okay. So foam is used for firefighting purposes, especially oil fire. Hmm. Used on oil ships, and then there are two types: low density foam and high density foam. It will be relevant to ask you where the low density foam is used and where the high density foam is used, on deck or engine. What do you think on deck? You use low density foam or high density foam? And what do you think you use foam in the machinery spaces? Low density or high density foam? Think about it. I will give you answer as I come towards the end of this course. TLB, threshold limit, time weighted average. Concentration of a substance which nearly all workers may be repeatedly exposed to for a normal 8 hours working period without any adverse effect. That means certain gases can be present if, as long as their TLB value is below certain limits of that particular gas. Then the worker can continue to work in that area for 40 hours a week, that means 8 hours every day, without any adverse known effects. Hypermesh, which was earlier also said, a suppression of the atmosphere of very fine droplets of water usually delivered at very high pressure through the hypermesh nozzle for the firefighting. So I was just told you what is the high density and low density foam. On deck, when you have to fight fire, you use high density foam. In the machinery spaces, low density foam is used. Because for the same amount of foam compound, you get larger amount in low density. That's why low density low. Why we use high density on deck? Because it's a bit denser, otherwise there are chances of it will blow off with the air, where the ship is moving, or the air which is surrounding. All right, that's the only thing. So this is the end of module 2. Relevant definition and terms. Some more definition if it comes, I will explain as they come. So shortly I will be preparing another module, chapter 4, module 2. Very important. Actually, all modules are important. Stages of fire. What is incipient fire? Huh? What is the fire at its full glory? How does the fire looks like when it is dying? All this we'll learn in stages of fire. Meanwhile, as I said, learn about what is Guru Dakshina. It's a Sanskrit term. It is being used in the Gurukul system of India for a long, long time. So it is a voluntary contribution as per your wishes, or as per the wishes of the disciple, and is offered to his Guru on his own free will to learn his blessing, to have his blessing, continuous blessing throughout your life. So this is my address, https://paypal.me/DCE Prof. What is DCE Prof? Is my address actually. Delta, Charlie, Echo, Papa, Romeo, Oscar, Foxtrot. All right. Thank you very much. I hope you enjoyed it. Have a good day.